Hello everyone, today we'll be going through Ionic Lewis diagrams, alright? We went through covalent last time, so now we'll do ionics. So, ionic compounds is a compound between a metal and a non-metal. We should know that, but just a reminder. So, the first step is to find the amount of valence electrons. We'll call it VE in this video. VE, the amount of VE each element has. So, how much does sodium have, and how much does oxygen have, alright? Now let's look. So the rule is we look at the columns, right? They have numbers at the top. They go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So when looking for valence electrons, we only use 1, 2, 13, 14, 15, 16, 17, and 18. So group 1, column 1, has 1 valence electron. Group 2 has 2. Group 13, 3. Group 14, 4, 5, 6, 7, 8. Continue. Right? So our first one, what was it again? We had sodium. So we can find sodium in this table, and we can see that sodium has 1 valence electron. So we can write that down here, 1. And then oxygen. Oxygen should have 6 valence electrons, right? It's in group 16. 6. All right. Now, we can see that we have a subscript here, 2, which means we have 2 sodiums. So how many sodiums do we have in total? How many valence electrons we have in total? We have 2. And oxygen, we have 6. So here's the rule. The metal, which in this case is the sodium, likes to give its electrons to the non-metal. And this is the case for most of the compounds. So what happens is we have our sodium, right? We can write it. This. It had 1 valence electron. And then we have another one of these sodiums. And had 1 valence electron. And then we have our oxygen. It had 1, 2, 3, 4, 5, 6 valence electrons. So the sodiums like to give their valence electrons to the oxygen, right? So what happens is it literally just gives it to the oxygen. This one goes to the oxygen. So does this one. So when we draw it, we can erase it. And then we can give the valence electrons to the oxygen. So now the oxygen has a full circle of 8. So now that we have this, we have to look at the charges of each one. So what is the charge of an electron? It is negative, right? So if we lose negative 1, for example, from 2, what do we get? If we lose negative 1. So we subtract negative 1. Well, we add 1, right? So in this case, sodium, right? We had our valence electron. We lost it. So we lost a negative. So we gained a positive, right? So it has a charge of +1. And both sodiums have the charge of +1. Why? Because they both gave their valence electrons to the oxygen. Well, now, the oxygen gained 2 electrons from these 2 sodiums, right? So if I add 2 negatives, that means my oxygen now has a charge of -2, right? Because it gained 2 electrons. So this could be my completed Lewis structure. Although we should make it neater by erasing one of the sodiums, and we can write a large 2 in front of it. Why? Because the 2 sodiums were exactly the same, right? They were both sodium plus 1. So we can just add this large coefficient at the front to indicate that we have 2 sodiums. So now we have our completed Lewis structure, and we can go through one more example. So in this example, we go through the same steps, right? We have calcium and nitrogen. Let's look at this, calcium and nitrogen. So now let's go back to the periodic table. For calcium, we gotta find it on this periodic table, and we found it here. So calcium has 2 valence electrons. So let's write that down. And the next one is nitrogen. Nitrogen has 5 valence electrons. And look at this. We have 3 calcium and 2 nitrogen. All right? Simple math. Now let's write out our calciums and nitrogens. I don't like to go straight to a 2 coefficient. I like to write out each step so we can see what we have and we won't make mistakes. Well, less chance of making a mistake. So let's have our calcium 1, calcium 2, calcium 3, and nitrogen, and nitrogen. Alright, now let's give them their valence electrons. 1, 2, 1, 2, 1, 2. And then we can give our nitrogen its valence electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, now let's look at this. So from the calcium side, we have 6 valence electrons. And from the nitrogen side, we have 10. So, as I said before, calcium, the metal, likes to give its valence electrons to our nitrogen, right? Well, in this case, we don't have a very even or pretty amount of calcium and nitrogens to do the swapping, right? So here's how I like to think about it. For our nitrogens, there are 10 valence electrons right now, right? But each one wants, how many does each one want? It wants 8, right? 2 times 8 is 16, right? It wants 16 valence electrons in total as a group. Well, where are we going to get those? The calcium is going to give it to it, right? And from our calcium, we have 6 valence electrons, which means the calciums are going to give all of their valence electrons to the nitrogen. So here's how we're going to represent it. So first, from the first calcium, we're going to take its valence electrons, and we're going to put it on the nitrogen. Alright? And then we're going to erase it from here. And now we're going to take the second ones, we're going to add it to this one, and then we're going to add it to the next one, and then we're going to erase it. And then the last calcium, it has 2 more, so we just add it here, 2 more, and then we erase it. Alright? Pretty simple, right? Let me just erase the highlights, it's kind of confusing. Alright, that makes a lot of pretty good sense, right? We just give the valence electrons from the calciums to the nitrogens. And then we can erase the numbers. So what do we get? We now have 2 nitrogen elements with their satisfied 8 valence electron shells, right? Now, if you think about it, how many valence electrons did each one gain? Now, if we think about to the start, each one had 5 valence electrons, right? Now they have 8. So 8 minus 5 equals 3. Each one gained 3 valence electrons. Valence electrons are negative, right? Like we talked about up here. Since they're negative, that means each one has a charge of negative 3, because they gained 3 negatives, right? Now we look at the calcium. At the start they had 2, right? And now they lost 2. Now they have 0. That means they lost, well, if you think about it, they lost 2 valence electrons. And we already know that. We don't need to do the math for that, right? We know that they each lost 2 of their valence electrons. When you subtract a negative number, because electrons are negative, right? We get positive. So now the calciums aren't negative anymore. We give them plus 2 each, because they lost 2 electrons each, which means they're now positive, right? And now we have our Lewis structure. Obviously, we should make it more clean, right? So by doing that, we just erase the extras, and we write 3 to represent 3 calciums, and then I'll erase this one. And then we can write 2, alright? We should probably space them out a bit to make it clear. So now we can see we have 3 calcium with a charge of plus 2, and 2 nitrogen with a charge of negative 3. And there you have it. Now you know how to draw an ionic compound as a Lewis diagram. And if you watch my other video, you also know how to draw a covalent compound. Thanks for watching, everyone. If you were helped by my video, consider subscribing, liking, and commenting any questions you may have.